Hey, this video is going to be about the January exam practice that we received in class for the paper 1. So, the first question here is a geometry problem, 3 dimensions, but it's okay because we're given this handy formula from the formula booklet. The information we're provided is the area of the square at the bottom, and we also know that the entire volume of the pyramid is 36 root 3. So, volume is equal to 1/3 of the base of the area times the height. And we are solving for the height right now because we want to be able to use our trig principles to be able to find this angle theta. So let's see, our volume is 36 root 3, which is equal to 1/3 of the area, which is 36, and then times the height, and we're just going to solve for h. We're going to divide both sides by, well, 1/3 times 36 is 12, and 12 divided by here, 3 root 3. 3 root 3 is our answer for h. So we know that this component here, 3 root 3. And to figure out this angle, we either have to have the hypotenuse or find the base. And we're going to find the base because we have this handy information given to us that the area of the square is 36, which is a perfect square, which means that the sides are 6 and 6. And of course, if you look at this diagram, this line here is half of the length of the square. So this is 3. So we know that this is 3. I'm going to draw the triangle again over here. So we have 3 root 3 as one of our sides, 3 here, our right angle, and we're looking for the angle theta here. So you'll notice that this is a similar triangle with a triangle you should be familiar with in your trig. It is the root 3, 1, and 2 triangle, and this angle will be pi over 3 or 60 degrees. You'll notice that each angle, each side was multiplied by 3, but that does not change the angles within the triangle, and that will be the answer for the first question. For the next question here, I'm going to skip over the probability question, that is question 2, because we don't need to know it for our January exam. So the question tells us that there is a 2-digit number n, which is written in the form 10a plus b, where a and b are integers. So they're an element of the integers. The 2-digit number m is formed by reversing the digits of n. Express m in terms of a and b. So you'll notice that for example, like a number like, I don't know, 82. This is the same as 80 plus 2. So a here is 8, and you're having 10 times 8 plus b, which is 2. And that's how they're choosing to compose their numbers, their 2-digit numbers here. And since we're using a 2-digit number, we can flip these two numbers. So we'd have 10b plus a. So for example, if we had that 82 had a equals 8 and b equals 2, flipping these values in 10b plus a would give you 2 times 10 plus 8, which is 28, which does indeed flip the 2-digit number we had in mind. So this works. Okay, so that's how we're going to express m in terms of a and b. That's 1 mark already. And hence or otherwise prove that the difference between a 2-digit number and its reverse is a multiple of 9. So what I'm going to say first is that 9 times any integer, let's say k, this is the definition for a multiple of 9, provided that k is an element of the integers. So let's do the subtraction of n minus m. This is going to be equal to 10a plus b minus 10b plus a. Don't forget your brackets. You'll see that this will be 9a minus 9b. And from here we can factor out 9. And you'll notice that since a and b are both integers, the subtraction of a and b must also be an integer, meaning we have the form 9 times an integer k, and this proves that the subtraction of n and m will result in a multiple of 9. Okay, for the next question here, you're going to need to use calc. We're given the prime function and we need to find the original function, and then we're also given a point so we can find the constant c. So h of x is going to be equal to the integral of h prime of x with respect to x. So let's do that. The integral of x times root 1 minus x squared, and I'm going to dx, and I'm going to write this part as u. Let 1 minus x squared equal u, and that means our du by dx is going to be equal to negative 2x, right? And I'm going to solve for dx. Dx is going to be equal to du divided by negative 2x. I'm going to plug in our new values. X times the square root of u. I'm going to write that as power of 1/2. So u to the power of 1/2. And dx, we're going to plug in our new found dx. Du divided by negative 2x. You'll notice here that this x and this x can cancel cleanly. And we're going to have integral of u to the 1/2 times negative 1/2 du. This can be pulled out to the front because it's just a multiplication of a constant. So this is negative 1/2 u to the 1/2 du. Since we have respect to the same variable, we can just use the power rule like this. And we'll have negative 1/2 times 2 over 3 u to the 3 over 2, and then plus c. The 2 here and the 2 here will cancel, giving us negative 1/3. And I'll plug in our original value. So we'll get 1 minus x squared to the power of 3/2 plus c. And to find c, we're going to plug in our point h of 0, which will equal, and we're going to use the original, we're going to use this new function, negative 1/3, 1 minus 0 squared to the power of 3 over 2, plus c is going to equal 2/3. So 1 minus 0 is just 1, and once the power of anything is just 1, so this part is negative 1/3 plus c equals 2/3. We're going to add a third to both sides, and c is going to equal 1. And our final function, we're going to replace the c here, is just all of that. So this next question here is a transformations and graphing problem. And we're giving these 2 points, and we can see that this center point here is the y-intercept. What they're asking us to do is draw this new transform version. And if you remember from the transformations, that this is our formula for determining the transformed function. You'll see that a and d are actually vertical components, and they're not included on this function, meaning we know that the y value of all these points do not change. So all we need to do is look for using x over b plus c, which tells us the new transform point on a transform graph from an old point. We need to find these points of significance and then kind of just draw it. So our b lines up to be 2, so b equals 2, and c equals 2, not negative 2, because we have a negative sign here. So let's start with this y-intercept. So it'll be 0 over 2 plus 2, which equals 2. And I just said the y value won't change because we have no transformation or translation vertically. So it'll be a height of 2 and at the x of 2 right here. I'm going to use orange. Our other point, let's do the maximum here. Negative 1 over 2, so it's negative 1/2 plus 2. So we'll have 2 and then minus 1/2 is here, and the y value was at 3, so it's around here. And that just means our other point will be right here. And our graph will look something like this. And it goes down to 1, so it looks like this. And make sure to go through all the points, unlike me. But yeah, something like that. And notice that we only have to draw it for this domain, since that was the domain offered here. And our new transform domain will look like this. So yeah. Also, please remember to label all these points with the values you just obtained, but yeah. And now for this question here, we have to work with logs, and this isn't too bad. So the natural log of x plus the natural log of x minus 2 minus the natural log of x plus 4 equals 0. So if you remember, when we have the addition of two natural logs, the arguments will multiply, and a subtraction means a division. So we can write this as one big natural log, x times x minus 2, all divided by x plus 4, which will equal 0. And we can raise e to the both sides. So we'll get that x times x minus 2 over x plus 4 equals e to the 0, which of course is 1. And now we have a little expansion here, x squared minus 2x divided by x plus 4 equals 1. I'm going to multiply both sides by x plus 4 to get x squared minus 2x equals x plus 4. And I'm going to rearrange terms. X squared minus 3x minus 4 equals 0. And now, just to solve this quadratic, we're going to factor it. We need a value that multiplies to negative 4 but adds to negative 3. We need two values, I mean. So that will be x minus 4 and x plus 1. Minus 4 plus 1, negative 3, equals 0, which means our x values are either positive 4 and minus 1, except we're working with logs, so we know the domain cannot be negative, so we cancel out this value, and we only have the positive value. So, next part, log base 3 of 4x squared minus 5x minus 6 is equal to 1 plus 2 log base 3 of x. 1 plus 2 log base 3 of x. Now this is going to require to use a bit more of your logarithm knowledge. So 1, we're trying to get to the same base as everything. And we could raise both sides to the power of 3 like this, but this would take a little bit more working. So I'm going to instead write 1 as log base 3 of 3. Because log base anything of itself is just equal to 1, right? So log base 3, 4x squared minus 5x minus 6 equals log base 3 of 3 plus 2 can be written as an exponent for the x. So log base 3 x squared. And now we just have a multiplication here. And we can raise 3 to both sides. So we're going to get 4x squared minus 5x minus 6 equals 3x squared. And we can subtract this from both sides. 4x squared minus 5x minus 6 equals 0. And similarly, this is going to be x minus 6, x plus 1 equals 0. And of course, we cannot have the positive, we can have the negative value. So we only take this one. For the next question here, we're given a graph cosine x plus sine x for a specified domain. And we have the y-intercept, and we know that the maximum point A is at a value P, comma Q. And there's just a minimum point at B. And the first part asks us to prove to find f prime of x. So that's relatively easy. F prime of x. We had cosine x plus sine x, so negative sine x plus cosine x. I'm just going to write that in this order. Cosine x minus sine x is our derivative function. And hence, it tells us to prove that q, from up here, q equals root 2. So to find where we have a maximum, and then hence find the y value later, we need to find the x value, p, first. So we need to do f prime of x equals 0. So I'm going to set cosine x minus sine x to 0. And this is interesting. We can move sine x to the other side, add sine x to both sides. This is just one specific trick you'll have to remember. And then we're going to divide both sides by cosine x. So we'll get cosine x over cosine x is 1. Sine x over cosine x is tangent x. And now we need to use the unit circle to find where this is true. So our values of x, if you remember, opposite over adjacent. So we'll need 1 and 1 here. And we'll have 2 values because there's another quadrant where tangent is positive, where it's -1 and -1, and they cancel out. And this value, of course, is pi over 4. So we know that x will be equal to pi over 4. And this is pi plus pi over 4, which is 5 pi over 4. And of course, you could try to figure out which is the maximum and minimum using the second derivative test, which I think the question asks you to do later. But straight away, we know that pi over 4 is less than 5 pi over 4, so this one must be pi over 4. So p is pi over 4. If that's true, then we just need to find f of pi over 4 to find q, which should turn out to be root 2. So our original function was cosine x plus sine x, so cosine pi over 4 plus sine pi over 4. And we need to find what this equals. we can do this with a triangle. So we have the angle pi over 4, which means this is 1 root 2. And yeah, for cosine and sine, they give the same value. They're both root 2 over 2 after rationalize. So this is equal to root 2 over 2 plus root 2 over 2. And 2 halves of the same thing give you the thing, which is root 2. So that proves that Q was equal to root 2. And it says to verify that A was a maximum, and I guess when IB asks you to verify something, they want you to take the second derivative and check for sure. So we'd have to find where the second derivative is less than 0. So to find the second derivative, we had cosine x minus sine x, so second derivative is just going to be equal to negative sine x minus cosine x. Very negative. All right. And we need to check that at pi over 4, f prime of pi over 4 is indeed less than 0. So we'll plug in our values. This is going to be negative root 2 minus root 2. Negative root 2 minus root 2. Is it less than 0? Well, of course, this is negative root 2, and that is less than 0, meaning this is indeed a maximum. And the next part tells you to state the coordinates of B. That's easy. We already have where the local minimum must be. So we know that B, the x value, must be 5 pi over 4. And to find the y value, we plug into our function, 5 pi over 4, to find the height we're at that point in the graph. So our function was cosine x plus sine x, 5 pi over 4. So we will need to use the unit circle for this one because this is a quadrant where they are both negative. And since they're both negative, then we know that this is negative root 2 over 2 minus root 2 over 2, which is equal to negative root 2, which just so happens to coincide with the answer we had earlier. They have nothing to do with each other. But you could also just take a look at the graph and notice that, well, there's no vertical transformation. So that means there must be an amplitude change since this is a periodic function. If it's multiplying by root 2 and going up to root 2, then it must also go down to negative root 2 since it is periodic. And that will help us with the next part of the question, which asks us to write the function x in the form r times cosine of x minus c, where r and c are real numbers. And the value of r will be the amplitude of the outside, since we're multiplying outside. And as I just explained, it's going to be root 2. So r equals root 2. And there is a transformation to the right. So we know that cosine starts at 1 and goes down like this, but our graph kind of looks more like this. And we know that the peak here was at pi over 4, but the peak here would be at 0. So it has shifted over by pi over 4. So that means our answer for C is pi over 4. So now we have what is probably the hardest question on the paper, where we're given this function and there is a nested function in the denominator. So this is e to the power of x squared, not e to the power of x, and then all of it squared like that. So the first part asks us to find, show that there is one maximum point P, and then asks us to find the x value of P. So to find out where our maximum point is, or how many we have, we need to find the derivative. So I'm actually going to rewrite this as x times e to the negative x squared, since that would mean put it in the denominator. It's a negative exponent. Because I don't like using the quotient rule, I'm going to show you how to do this with the product rule. So it is the same thing though. G prime of x equals the derivative of the first function times the second function plus this times the derivative of the second function. So derivative of the first function, the x, 1 times e to the negative x squared plus x, and then we need to find the derivative of this. So I'm going to write this as x e to the u, where u is going to be equal to negative 2x, or sorry, negative x squared. Because when we're deriving e to the power of u, we need to do e to the u times u prime. So this will be e to the power of negative x squared, and then further multiply by u prime, and u prime is going to be negative 2x because of the chain rule. So times negative 2x. So let's write this a bit better. So this is going to be 1 divided by e to the x squared plus negative 2x times x. It's going to be negative 2x squared divided by e to the x squared. And of course, you can all write this all as one function. So this will be 1 minus 2x squared divided by e to the x squared. And since we're looking for a local minimum or maximum, we're looking for the maximum, we're going to set this equal to 0. You can multiply both sides by e to the x squared, so this does not matter. 1 minus 2x squared equals 0. So 1 will equal 2x squared, and we're going to solve. 1 over 2 equals x squared. And you can take the square root of both sides, plus or minus. But look at our domain. Our domain is only valid for greater than or equal 0, so we can omit this negative sign. And you should know that this is root 2 over 2 equals x. So that is where the maximum value is, and that's how we show that there is only one. The next part asks us to show that g has a point of inflection, q, at x equals root 3 over 2. And this is tricky because we have to find the second derivative of what we just had here. So we had g prime of x equals 1 minus 2x squared divided by e to the x squared. To find g prime prime, I'm just going to use the quotient rule. So this will be equal to the derivative of the top function, which is going to be negative 4x, times the entirety of the second function, subtract the entirety of the top function, 1 minus 2x squared, and then times the derivative of the second function, which we know is 2x e to the x squared. And yeah, this is kind of messy, but all we need to do is set this equal to 0. We'll have negative 4. Well, actually, they're telling us that x at root 3 over 2, they're telling us there is an inflection point here. So what we're going to do is g prime prime of root 3 over 2, when plugged into this, negative 4 times root 3 over 2 times e to the root 3 over 2 squared is 3 over 2 minus 1 minus 2 times root 3 over 2 squared is just 3 over 2. So these 2's will cancel, times 2 times root 3 over 2, and once again, e to the 3 over 2. And this should equal 0, right? It should equal 0 for there to be an inflection point here, because that's what the second derivative test tells us. And you'll notice that this is equal to, let's simplify this a bit, negative 4 root 3 over 2 times e to the 3 over 2 minus 1 minus 3. So this is negative 2. So this is minus negative 2 times 2, which is positive 4 root 3 over 2 times e to the 3 over 2. And we have the same thing, negative and a positive, so this cancels out and equals 0. And that's how we show that there is a point of inflection q at x equals root 3 over 2. Next, it tells us to determine the intervals on the domain of g, where g is concave up and where g is concave down. So instead, we take our g prime prime x, which was this long annoying thing here, equals, I'm going to simplify this part out a bit, so we'll have the negative times the negative. Or sorry, we have, actually I'm not going to do that because that would be an annoying expansion, but we just need to find where this is less than 0 and where it is greater than 0 for concave up and concave down. So let's see. For less than 0, we need negative 4 x times e to the x squared minus 1 minus 2x squared times 2x e to the x squared. And we need to find where this is less than 0. So yeah, this is kind of annoying, but let's move the entire thing over. Negative 4x times e to the x squared less than 1 minus 2x squared times 2x e to the x squared. I see a common term here. I'm going to divide both sides by e to the x squared. I'm going to divide both sides by 2x. So I'll be left with negative 2 here. So negative 2 must be less than 1 minus 2x squared. I'm going to subtract 1 from both sides. Negative 3 must be less than negative 2x squared. If we make both sides positive, then we must flip the sign. So 3 is greater than 2x squared. Divide both sides by 2. Then take the square root. 3 over 2 must be greater than x squared. Plus or minus, but of course we know that x cannot be negative, so we have plus 3 over 2 is greater than x for the concave up, and you would basically just do the same thing for concave down. And it should show that it should be past this point instead. So now what we have is probably the hardest part of the paper. It tells us to find the value for k, where the region bounded by the graph of g, the x-axis, and the vertical line x equals k, has an area equal to 1/2 minus 1 over 2e to the 4th. So to visualize what this means, I'm going to draw a random function. This is not what the graph looks like, but say it looks like this. Then we're going to have a dotted line, x equals k, which is the cutoff point, and the x-axis here. And this is the bounded area they mean, because this is g. This is the bounded area they mean. And from 0 to k, it should result in some area, which is 1/2 minus 1 over e to the 4th. So to find this, we need to integrate from here and use the definite integral. So we'll have the definite integral from 0 to k of x over e to the x squared with respect to x. So I'm going to let u equal to x squared to make this simpler. And our du over dx is going to be 2x, right? From here, we're not going to be able to plug in and solve here because the x squared will not be able to cancel, but we can make this a little simpler. So du over 2x, I'm going to do it anyway, equals dx. So the integral from 0 to k with our new terms, x divided by e to the u, and dx is du over 2x. So x and x will cancel, and we'll have u du. So you'll notice that this is the same as 0. This is 1/2 because we had 1 over 2 du here. So 1 over e to the u du. So from here, we need to recognize that this is a negative exponent for e, because I don't want to use another chain rule and have the natural log or something. So this is e to the negative u with respect to u. And of course, when we're integrating by this, we have to divide by the chain of this, which is just -1. So dividing by -1 just makes it negative. So we'll get that the function we need is 1/2 times negative e to the negative u from 0 to k. And I'm going to plug in our u value again. So this is the integral from 1/2, -1/2 then, because I'm going to move it to the front. 1 divided by e, and our u was x squared, and we go from 0 to k. So we have to prove that this equals 1/2 minus, sorry, not prove, but solve for k, where it equals to this area. So let's plug in our values. So we're going to have -1/2 times 1 over e to the x squared, which is k squared, minus -1/2 times 1 over e to the x squared, which is 0 squared is just 0, should equal 1/2 minus 1 over e to the 4th. So slight correction from here, the area was actually 1 over 2 e to the 4th, and that makes a lot more sense for me now. So 1 over e to the 0 is just 1, so because -1/2 times 1. So we'll have -1/2 times 1 over e to the k squared is 1 divided by 2e to the k squared plus 1/2 equals 1/2 minus 1 over 2e to the 4. And you can do this by inspection, but let's solve. Subtract 1/2 from both sides, make both sides positive, cancel out this, and raise both to the negative power. So we'll have e to the k squared equals e to the 4. And that means that k squared must equal 4. And k is equal to plus or minus 2. But as we know, we cannot have a negative value here, I believe. Yes, because we are looking for where the graph is positive here. So I just want to wish everyone good luck on your exams, and don't forget to revise math.